to Exception Handling, with the subtitle, Robust Error Management with Exception Handling. Here, we will cover how to implement effective exception handling techniques in your Sheerpower applications. By mastering these methods, you can ensure your programs gracefully handle errors and maintain stability. Let's delve into the best practices for robust error management using exception handling in Sheerpower. Exception handling routines intercept runtime exceptions and execute a block of code which handles them. If there is no exception handler, Sheerpower returns an exception message specifying what the exception was and where it occurred. Sheerpower stops program execution or tries the offending statement again. There are two types of exception handlers: attached handlers and detached handlers. Attached handlers are the most commonly used handlers. They are similar to the try-catch blocks that other languages provide. For an attached handler, a when exception in statement is used. When exception in expects the use block right after the block of code it protects. For a detached handler, the statement when exception use is used. When an exception occurs in the protected block, when exception use calls a handler routine located in some other part of the program. The same handler routine can be used by any number of when exception use statements and can be placed anywhere in a program. Let's discuss the functions related to exception handling in Sheerpower. The following functions are used for managing exceptions. _error, this function provides the current error code. EXType, this function returns the exception type number. EXLabel, this function gives the location in the code where the exception occurred. EXText, this function provides a user-friendly description of the exception. SysText, this function offers an operating system description of the exception. These functions are essential for effectively managing and debugging exceptions in your Sheerpower applications. Let's explore the statements related to exception handling in Sheerpower. The following statements are used for managing exceptions. Continue executes the next statement in the sequence. Retry retries the offending statement that caused the exception. Causes an exception by type number, allowing you to trigger specific exceptions for testing or handling purposes. These statements provide control over the flow of your program when handling exceptions, ensuring that you can manage exceptions effectively. Let's look at an example of using an attached handler in Sheerpower. The when exception in block is used to protect your code. If an exception occurs within this block, the use block will handle it. Here's how it looks. In this example, when exception in, this block contains the protected code where exceptions might occur. Use, this block handles any exceptions that are thrown within the protected code. End when, this marks the end of the exception handling block. This structure helps ensure that your code can gracefully handle errors and continue executing. Let's look at an example of using a detached handler in Sheerpower. The when exception use statement calls a separate handler routine. Here's how it looks. In this example, when exception use specifies that a separate handler routine, fix_average, will be used for exceptions. Protected code, the code within the when block attempts to calculate the average. Handler routine, the fix_average routine handles any exceptions that occur. Exception handling, if an error occurs, fix_average sets average to 0, prints an error message, and continues execution. This approach allows for organized and centralized exception handling, making your code easier to manage and debug. In conclusion, effective exception handling is crucial for robust Sheerpower applications. By using attached and detached handlers, along with the related functions and statements, you can ensure your programs gracefully handle errors and maintain stability.